Hello everyone. In this video, we are clearly going to understand how we can leverage AutoGen as a framework for creating multi-agent systems. So when I say multi-agent systems, we are looking at creating multiple agents which interact well with each other and try and solve a specific problem here. So AutoGen, as you know, is an open source programming framework offered by Microsoft. This is specifically used for building multi-agent systems like what we are talking about. So if you are looking at this particular block diagram, it clearly gives us a perspective on the different types of agents that we can create. So the very first one that we are looking at here is LLM agents, the agents that can integrate well with large language models. So the large language models here could be GPT-3 or GPT-4o, or it could even be Mistral AI like I have mentioned in the previous session. So the other types of agent could be tool agents, which interface well with the organizational specific APIs or databases. Let's say we are working with a large e-commerce platform like Amazon. So Amazon will have its own APIs and databases, which basically would refer to the consumer data. So using these consumer data, so if the agents are using these consumer data, then we might end up providing more personalized recommendations to the end consumers or users here. So the third one here is human agents. So the agents which expects human input. So based on the human input, the agent generally changes the environment dynamically and try to adapt to whatever input that the human is providing in between. So this is like human in loop. Okay. So these are broadly three different types of agents that I have listed down here. So all of these agents interact with chat here, which is there are some conversational interactions that occur between these agents, which we'll practically demo in our next session. And here we also have this task coordination. So task coordination or orchestrator, as we can say, is responsible for understanding which agent to call first or prioritize the different agents and try and get tasks done by specific agents by reasoning it well. So we clearly have also understood what exactly is React framework. Like based upon the user input, we clearly understand what the intent of the query is. So once we reason it well, we typically look at actioning upon whatever input that we have received by reprioritizing the different set of agents, which agent to invoke on what specific task to attain and all. So everything is determined by orchestrator here, right? So we can draw an analogy between the task coordinator that we have specified here with the orchestrator that we have already discussed in the previous session. So finally, what we are essentially looking at is, so the end objective here is to perform and complete the task with or without human input. So this is a whole approach in multi-agent framework that we can right now discuss. So what are the two different features that are offered by the AutoGen agents that we will end up creating? One of which could be the conversible nature of it. The other one is the customizable agents that we can create. The customizable agents generally can integrate with any of these. Could integrate well with AI models, tools, humans, or combination of all of it. So the conversible agents, on the other hand, can simply send and receive messages or exchange information in between agents. Like if you're looking at the different built-in agents in AutoGen, so conversible agent is one of the most primary agents. Like we can consider this to be a base class. So all of these that you are currently observing are nothing but built-in classes within AutoGen package. The AutoGen package generally offers these different classes here. So conversible agent generally means that any agent can basically send and receive messages to and from other agents or initiate or continue a conversation that's existing, right? We'll understand it practically in our upcoming session. But whatever assistant agent and user proxy agent that you are currently observing are extended from this base class called conversible agent. You look at this particular flow diagram. So user proxy agent inherits all the properties and methods associated with conversible agent, which is the base class here. Similarly, assistant agent also is extended from conversible agent and GroupChatManager is not. So GroupChatManager is typically like an orchestrator which determines which agent to call when, right? Holistically, GroupChatManager is useful when you are having multiple agents collaborating to solve different problems or different tasks of a specific problem, right? And whenever you need a structured communication, like let's say that you would want to invoke agent 1, and based on agent 1's response, you would want to determine whether you need to call agent 2 or agent 3. So this is more like a structured collaboration that you can say, right? So that's when you need GroupChatManager, which typically acts like an orchestrator here. But let's not worry about GroupChatManager. And this does not extend from ConversibleAgent like AssistantAgent and UserProxyAgent. So UserProxyAgent, as the name itself suggests, the default value for this parameter called human input mode is set to always. So we always expect an input back from the human. So we always can change this parameter value and set this to never, and we need not expect the user input each time for user proxy agent call, right? So we always can change the configuration that's already provided by default, but the default behavior for user proxy agent, especially for human input mode, is set to always by default. So similarly for conversible agent, as you can observe, the human input mode is set to never. Code execution config is set to false. That essentially means that you need not execute any code. We are specifying the role of the agent here. Specifying the role of the agent is very helpful in a way that the agent will try to understand the real purpose of it, right? So assistant agent mostly integrates with LLM and typically acts as code generation tool. Here we are trying to generate the code and not executing the code as such. User proxy agent, on the other hand, can act as a code executor, right? If you observe this particular setting that I have provided, that human input mode is always by default set to always, LLM config is set to false, since we are not integrating user proxy agent with LLM, as you can see here. But as I have mentioned, user proxy agent can act as a code executor. So the default value for code execution config is set to true for user proxy agent, and it is set to false for assistant agent. So you can simply generate the code and need not execute it by using assistant agent. And for user proxy agent, the default value for code execution config is set to true. If you're sending any code via chat, then obviously it'll try to understand and execute it. You can pass instructions to execute specific blocks of code by using user proxy agent. In our next session, we'll simply create a user proxy agent, and we can also create assistant agent, which acts as an AI assistant, specifically has this access to this large language model to solve any needs or problems at hand, right? So we can create a couple of agents, one of which could be the user proxy agent, the other one is assistant agent. We'll try to understand how these two different agents interact well with each other, how user proxy agent will use the assistant agent in order to solve a specific task. Let's say that we are trying to generate the code, then assistant agent will take the help of LLM, which it's already integrated with, try to generate the code, and user proxy agent executes the code that you have or instructs to execute the code, whatever it is. If you look at this example that I have provided here, so there are a couple of agents, user proxy agent and assistant agent. So user proxy agent is sending a request to the assistant agent stating that plot a chart of Meta and Tesla stock price change in year to date values, right? So execute the following code. And finally, user proxy agent tries to understand that there is some error. The error is that the package Y Finance is not installed. The assistant agent generally asks to install the Y Finance package and then execute the code. So this installs the package and then probably goes about executing. So execution is handled by user proxy agent that we already have learned. So the user proxy agent generally acts as the code executor here. The assistant agent here typically acts as a code generator here. So it is using LLM to generate the code, stating that execute the following code. It's providing the code to execute, asking the user proxy agent to execute. But user proxy agent, while executing that code, found an error with a package. And then assistant agent gave an assistance stating that please install this. So the user proxy agent abided to that particular instruction and then installed that package and then generated this output. And you also can ask any revisions to it. If there is any error, it auto corrects, as we have already understood that the whole The multi-AI agent system works on React framework where the agents think out loud and tries to understand if there are any errors or problems in the flow. And if there are any problems, then it tries to understand what could be the error and what could be the problem. It tries to resolve the problem with the help of the large language models to which it's integrated with already. Okay. So that's pretty much all I wanted to discuss with you. I believe that you have clearly understood on the different types of agents that we can create and what are the different built-in classes associated with AutoGen as a whole. And Group Chat Manager, as I have defined here, is not extending the conversible agent, and we need not require Group Chat Manager always. We only would require Group Chat Manager when we would expect a structured collaboration between multiple agents, right? Whenever you are having complex workflows involved in the problem that you're trying to solve, then only you would need to have something like Group Chat Manager, which is analogous to the orchestrator that I have mentioned. If you look at this particular simple example that I have been discussing with you, we do not have a Group Chat Manager. So we only have the user proxy agent and the assistant agent. User proxy agent is acting like a code executor. Assistant agent is acting like a code generator here. And that's all. They talk to each other. They have this conversation ability since both of them are extended from the conversible agent class here. The conversible agent by itself has got this nature of exchanging the messages between the agents that we end up creating, right? So that's pretty much all I wanted to discuss with you in this session. And the next session, we are practically going to implement one use case or problem that we are considering. Okay, we'll create both user proxy agent as well as an assistant agent and try and initiate a chat between them and solve a specific problem and see how we can build this multi-agent system here. Okay, so that's all in this particular session. Thanks for watching.